Hi guys, today what we're going to talk about are trends that we see on the periodic table. Okay, first one, and we're going to get all these written down before we actually keep going, but the first one is the atomic radius of the atoms. Okay, so the atomic radius it's just like we're talking radius of a circle, but it's basically a measure of how big an atom is. So we're talking, take the whole atom, big circle, just half of it. Okay, so that's atomic radius. Next one is ionization energy. Okay, ionization energy is the energy that it's going to require to remove one electron from an atom. Okay, and this has happened when atoms bond with each other. We're taking an electron away or we're giving a different one away. So it's just this whole idea of how much energy it takes to steal an electron, give an electron away. Basically, it's how easily are these things going to match up. Things with really high ionization energy, it takes a lot for them to get an electron. Things with really low ionization energy, they give them away really easily, and so things bond very, very easily. All right, so our next one is valence electrons. This is definitely the easiest one to kind of understand in terms of what it is. We haven't talked about electrons yet. That's going to be our next topic. But what a valence electron is it's the electrons that are on the outermost energy level of an atom. So if you remember back to our pictures of the atom, we have the nucleus in the middle, and then around it we have different levels of electrons. Well, the valence electrons are the ones that are in the biggest orbit, essentially, for that particular atom. So some of them are the biggest orbits here, other atoms, the biggest orbits back here, and so it's just, we're kind of looking at that. But valence electrons are the outermost electrons, so in the biggest orbit for a particular atom. All right, and then the last one, and this one kind of goes along with ionization energy, and you'll find that they are very, very similar. Okay, it is electronegativity. Now, what electronegativity is it's the ability of an atom to take an electron. So ionization energy was how much does it, how much energy does it require to take an electron away. This one is the ability of an atom to attract electrons. And you'll understand kind of when we go with these, that they definitely go hand in hand. Okay, so now to the actual trends themselves. Here's our periodic table. I put it here just so that it's made really easy to see, and then we can get going from there. What I want to show you is we talk about trends. Oh, that line is a little bit big. It's all right. We'll get rid of it. There we go. Okay. Small line. We talk about trends as they go across a period and as they go down a group. So that's how we're always going to be talking about all four of these different trends. Okay, and then we'll kind of show you what those are. So all of these trends have to deal with electrons. And when we're going back to thinking about it, right, hydrogen up here is number one. It has one proton and one electron. Helium, number two, two protons, two electrons. Well, we can do that for every single element on here. Okay, if we go down to aluminum, okay, aluminum is right here. It's number 13. That means that it has 13 protons and 13 electrons. And those electrons are filling our atom, okay, in different orbits. And kind of the way that we want to think about it, so just preview. Okay, if the element is in the first row up here, then it has electrons that are in only the first orbit. If something is in the second row, then it's going to have electrons that are in the first orbit and a second orbit. Third row has electrons that are in the first orbit, second orbit, and third orbit. Okay, so you kind of get the picture here. First row has one orbit. Second row, all of these elements have two orbits full of electrons. Third row has three orbits that have electrons in it. Fourth row, four orbits, so on and so forth. Okay, so now that we kind of have that basic idea here, what we're talking about is atomic radius. Well, like you might imagine, is as we go down the periodic table, Okay, so as we go down a group, if number 1 hydrogen only has 1 orbit, it's not going to be very big. Okay, lithium is going to have 2 orbits, so does it make sense that it's going to be a little bit larger? 3 orbits larger still, 4 orbits larger, 5, 6, and 7. Okay, so it's just this whole idea that as we go down the periodic table, the atomic radius gets bigger. Okay, plus sign for getting bigger as we go down. Now, think about this again. As we go across the periodic table, okay, hydrogen has 1 electron, 1 proton as well. Helium has 2 electrons and 2 protons. Well, now we're getting more and more and more charge. Okay, that's basically more of a positive magnet, more of a negative magnet. And if we have more magnet, what's that going to do? Right? It's going to create a stronger pull and pull them together more. What that means is that as we go across the periodic table, it actually gets smaller. Okay, the atoms shrink because the positive protons in the middle are pulling more because we have more electrons, so they're getting squeezed together just a little bit. Okay, and that's kind of our atomic radius trend. We get bigger as we go down a group, and we get smaller as we go across the table. Okay, again, because of how much the electrons pull, and down they get bigger because we have more and more and more energy levels. All right, next one. Gotta delete some of that. We'll get it. All right. So our next one. There we go. Our next one that we want to talk about is ionization energy, and this is the energy required to remove 1 electron from the atom. Okay, and then again, this is kind of when they bond. So our ionization energy, let's just get you what the trends are first. As we go down a group, okay, the ionization energy gets smaller. The reason that it's going to get smaller is that as we get more and more and more energy levels going down the periodic table, what we see is that now they're farther away from the nucleus. Okay, the positive charge is in the middle. And as we get farther and farther away, well, these negative charges, basically it's like a magnet, right? A magnet's not as strong when it's really far away. Well, these guys out here, okay, they can lose it. Well, since it's easier to lose it, since the magnet's farther away, the energy is less. Now, as we go across the periodic table, though, okay, the energy gets bigger. Now, the reason for that is, as just like the atomic radius, the smaller it is, well, now the opposite's true. Okay, those electrons are closer to the nucleus, right? They're really, really close, and a magnet that is really close to each other is a lot stronger. Okay, so as we go down a group, the ionization energy gets smaller because the electrons are farther away, and as we go across a period, the ionization energy, okay, or the energy to take one of those things away, gets bigger because now those electrons and protons are a lot closer together. All right, so let's get rid of these guys real fast. Okay, and now we can start talking about valence electrons. All right, valence electrons, super, super, super simple. They're going to get bigger as we go across the period, and no change as we go down a column. Now, the reason for that is everything in the same column has exactly the same number of valence electrons. That's kind of what those columns tell us. And as we go across a period, well, each row we get 1 more valence electron. Only thing that's kind of tricky is these guys right here in the middle. I'm circling them. Okay, they're the yellow ones. They have kind of a weird number of valence electrons. We're actually not going to worry about those. But everything here has 1, 2. We skip all the middle. 3, 4, 5, 6, 7, and 8 valence electrons. All right, so that's our valence electrons one. All right, get rid of those, and we'll talk about our last one. Electronegativity. All right, so what electronegativity is it's how much an atom wants to steal electrons from somewhere else. We'll just go ahead and write in kind of what they are. As we go across the period, okay, it's going to get bigger. And this has to do with valence electrons. Okay, an atom wants a full outer shell, and that's when it has 8 valence electrons. Well, if it has 7, it's really, really close to 8, so it really, really, really wants one more. Okay, if it's at 6, well, it wants them, but it doesn't want them as bad because it knows, well, I got to work, twice as hard. So I still want it, but, I'm not quite as eager. Well, then if it only has 1 valence electron, it needs to get 7 to fill up its shell. So it's like, well, maybe I don't want to go steal 7 more. That just seems like a lot of work. So I don't want to do that as much. And that's kind of how it goes as we go across the periodic table. As we go down the periodic table, well, valence electrons don't change as we go down. Well, that means that the electronegativity really isn't going to change all that much, okay? So we're going to say it's going to be negative and just slightly, okay? And that's because it's farther away, so it's like, well, I really don't want to because my protons are in the middle. They have to reach even farther to get one. But basically we're going to have one of these two, okay? No change or slightly smaller as we go down. All right, guys, we're going to learn a lot more about these when we start talking about electrons, but these are the general periodic trends that I want to make sure you guys know and understand. All right?